Hello, ladies and gentlemen. Let's talk about truss calculations. So before you get into truss calculations, you should have already learned about free body diagrams, force vectors, how they work, how trigonometry is used to solve for force vectors, okay, and moments. So if you don't know those three things, you've got to make sure that you go back and look at those and look at the resources provided for those three ideas. All right. So you are going to be solving three trusses. One looks like this. Now your numbers will be different. Your angle might be different. Your applied force might be different, okay? But it's going to look basically like this with a pin and a roller. You'll have an angle probably given, or at least you'll have a side and a side and can figure out the angle. If you don't see actual values for the side lengths, you can count numbers in a grid, okay? Your second one will look like this with 5 total members and a pin and a roller, and your final one will look like this. It's kind of like this thing that's wall mounted because there's a pin on the side and a roller on the side. Okay, for illustration purposes, we're going to take a look at this one, and we will start with that guy. Now, I already started drawing a free body diagram here. So when you draw your free body diagram, you're going to label from left to right and bottom to top. Okay, so we went A, then we're over here to joint B, joint C, and joint D. We will, what I'm going to do is I'm going to do this one as my example, and then I will show you the other ones. And I paused for just a second because I actually forgot to include that angle right there. Okay, so continuing with the free body diagram, we've got our joints, okay? It says replace the pin with 2 reaction forces. My pin is over here. Now, some instructors will tell you to assume positive and put the arrow going to the right for an X and upwards for the Y. I just leave the arrowhead off, and we'll figure out whether or not it's which direction that arrow is going. Okay, so in the roller, it's perpendicular to where the roller is hitting, and we're going to put our reaction force over there, and then we will put in our applied forces. There's an applied force of 75 units. Could be pounds, could be newtons, could be whatever. And there's an applied force here of 220. Okay. Now we're going to label all of our forces and our joints. So we have here a reaction force. Okay, so the things that the pin and the roller are reacting to the applied forces. We have a reaction force at joint A, and it's going in the Y direction. Okay, actually, usually I make that little A a sub. We have a reaction force at joint D in the Y direction, and we have a reaction force at joint D in the X direction. Okay. Up here, we have a force because it's an applied force at C in the X direction. And down here, we have a force at B in the Y direction. All right. So now that we've got our pin is replaced with 2 reaction force, the rollers are correct, and the roller is replaced with 1 reaction force. We labeled all of our forces and joints, okay? And now we're going to record all of these over here in the summary box. It's hard to see. There's a little like thing saying, hey, we put all this stuff in here. So here we go. We have forces first. Let's do the forces that are applied. We have F, C, Y, whoops, that's an X, sorry, FCX, which is 75 units. You can call it pounds or whatever you want, but it honestly doesn't matter what units it's in. Going that direction, we have, sorry for the sloppy X, we have F, a force at B in the Y direction, and it is going at 220 pounds going that way. Okay, now let's continue. These two we know because they're applied forces, the rest we don't. So now let's put our reaction forces in. We have a reaction force at D in the X direction. We have a reaction force at D in the Y direction. We have a reaction force at A in the Y direction. 1, 2, 3, 4, 5 forces total, 5 forces total. Now we also have 5 members total. So we're going to list out those members. We have A, B. This is one member. This is another member because they are separate from each other at joint B. So one line does not mean one member. It's between joints. We have A, C. We have B, C. We have B, D, and we have C, D. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so now you're going to do that for the other two as well. But before I move on, I also included angles and distances, okay, on my free body diagram. All right, so for the second one, or actually it's your first one, we've got 2 reaction forces at the pin, 1 reaction force perpendicular to the roller. We've got 1 applied force. Now again, your numbers and your distances might be different, but your labeling should be similar. Your joint should still be bottom to top, left to right, okay? And so you're gonna have a list of your 1 applied force, your 3 reaction forces, 1, 2, 3, and your 3 members, okay? And the only one we know so far is the 1 applied force going to the right with a magnitude of 100, okay? Your third one, again, your distances, angles, and stuff might be different, but you should have basically the same thing here, okay? We've got a pin or a roller, sorry, reaction force, pin, reaction force, applied force, 4 total forces. The only one we know is this one going downward, okay? And then we've got 5 members, 1, 2, 3, 4, 5 listed here. All right, so that gets you your steps to get your free body diagram and your summary box complete. Next up will be to solve for moments and figure out what the force is at the roller.